Okay, dear students, in this video we are going to discuss the concept of simple regression. The regression is a very famous topic in statistics as well as in econometrics. Moreover, regression plays a role as a tool of management sciences, social sciences, as well as in business sciences. So let's start the detailed theoretical discussion uh, of regression. The concept of regression was first introduced by English biometrician Sir Francis Galton. The main idea uh, for introducing the regression that Galton wanted to analyze the heights of children and their parents, and for this he found that although tall parents have tall children and short parents have short children, but the average height of the children tends to step back or to regress towards the average height of all men. So this tendency towards the average height of all men was called regression by Galton. So this was the beginning of the term or a tool regression in the literature. But today, regression has a different meaning and a different definition. So let's start the modern definition of regression. The dependency of one variable, which we call the dependent variable, on one or more other variable, which we call the independent variable, is known as regression. So this shows that if we have a one dependent variable and one or more than one independent variable, and the impact of independent variable on the dependent variable is in our era is called regression. Okay, in this way we can say that the relationship between the expected value of the dependent variable and the independent variable is called regression. Okay, here we have another simple interpretation of the regression, that the dependent variable is assumed to random variable, whereas independent variables are assumed to have fixed value, that is because they are chosen non-randomly. So we can say that when we have a dependent variable and independent variable, so technically again we can say that the impact of deep independent variable on dependent variable is called regression. So there are two main types of regression, but regression have number of types, but here in statistics we are going to discuss two types of regression. The first one is the simple regression versus a multiple regression. Okay, when we have a straight line or a linear relationship, so normally regression simple, either you have a simple regression, either you have a multiple regression. Regression, we have to find two types of relationship as well. The first one is the straight line relation or linear relationship. Okay, the linear relationship can be further categorized that it may be positive, it may be negative, or maybe there is no relationship between the independent and dependent variable. Okay, the second type of simple and multiple regression is the curvilinear. You can say it a non-linear relationship. The non-linear relationship also have a three type of relationship, that positive relationship, negative relationship, and no relationship. So we can say that when you have a one dependent variable and one or more than three, four independent variable, and there the impact of independent variable on dependent variable is called regression. And there are two types of regression, simple and multiple regression, and these two types of regression give us two types of finding, that is straight line, a linear relationship, and non-linear relationship. Okay, There are some terminology for the independent and dependent variable which we can use in coming videos and coming sessions related to the econometrics and statistics as well. Okay, a variable whose variation we are trying to explain is a dependent variable. Our target variable is always is a dependent variable, because we are finding the variation of the dependent variable, while an independent variable is a variable that is used to explain the variation in the dependent variable. Okay, we can give the other names of independent and dependent variable. Independent variable, dependent variable. Independent variable we call the regressor variable, and dependent variable we call the regression variable. You can use these names alternatively. Okay, independent variable we call the predictor variable sorry, and the dependent variable is the predictant variable. The other name of the independent variable, the response variable and the respond variable. Dependent variable, it is respond. Explanatory variable and explained variable. The first independent and dependent variable and explanatory and explained variable is extensively used in literature. When you are going to be a research student, you can learn these explanatory variable and explained variable have been used. Okay, there are two types of relations which the regression give us while studying, that is deterministic and probabilistic relationship or model. Two types of relations we are discussing in the regression, that is deterministic and non-deterministic. You can say it a non-deterministic. Okay, the relationship among the variable may or may not exact. Sometimes you find an exact relationship, and sometimes you find a not or inexact relationship. While talking about the natural or mathematical sciences, you always find an exact relationship between the variables, but in case of management, in case of behavioral sciences, there is not always an exact relationship between the variables. Okay, let a set of n pair of observation. We have a two variable xi and yi. Here we can say that y is a dependent variable and x is an independent variable. If there is an exact relationship, then the mathematical equation become as, if you say that all the variation in y has been explained by x, so this is an exact relationship. So there is no concept of remaining thing. So when there is no nothing unexplained in dependent variable, we can say that it an exact relationship. Okay, the linear relationship in such cases is said to be deterministic model. So when you have this type of model, we can say that this model is a deterministic model. Okay, there are some real example that when you are measuring the Celsius Fahrenheit heat, and this formula can be used, and every time this relationship will be exact. And when you are measuring the area, every time this formula will give you a exact result. So when this exact relationship existed between dependent variable and independent variable, we can say this is a deterministic model. But in real life, or especially in case of behavioral sciences, we cannot find such situation where the exact relationship among the variable existed. Like we have a very famous example, person weight and height. You can believe that the height of a person can determine the weight of a person, or weight of a person can determine the height of a person. So there may be a chances when a person have a tall height, but he has a less weight. But maybe a person have a high weight, but his height is is a normal or moderate height. So like that, the taste and behavior of the people is changed all the time. So there is not an exact relationship existed between variables. So in this case, estimating such variables is better to include the measurement error. So for the measurement of such type of inexact or not exact relationship among the variables, you can include or you can measure the errors where the other variation or where the unexplained variation is gone. So for the non-deterministic relation, you can use yt is equal to beta alpha plus beta xi plus ei. Here ei is the measurement of error. Here E is also explaining that variation which is not explained by the independent variable. So this is called the non-deterministic or probabilistic relation or model. So here you can see that EI are the unknown random error which is not explained by this independent variable. So this is called the non-deterministic model or relation among the variable. So whenever you have deterministic or non-deterministic relationship among the variable, you have to draw these variables in the form of scatter diagram. Okay, a first step in finding whether or not a relationship between two or more variable exists is to plot each pair of independent variable observation xi, yi, like here I, the subscript I explain that number of observation 1, 2, 3, so on n. So I explain how much number of observation you are going to include in the. Okay, x-axis has been used for independent variable and y-axis has been used for dependent variable. Okay, such a diagram is called a scatter diagram or a scatter plot. Let's draw this graph. Let's say we have a x-axis and we have a y-axis. Okay, we can write it an x-axis. Here we can say that x variable, and here we can say that a y variable. Okay, let's say we have y value and x value, so we can put it, this is for the x value and this is for the y value. Okay, this is for the x value, this is for the x, and this is for the y value. You can say that different type of outcome for the x and y are given here. Okay, see, this is a scatter diagram. So we can say such a diagram is a scatter diagram, or you can say a scatter plot. Okay, what the use of the scatter diagram is actually in this case, or why we have drawn the scatter diagram here. We have a dependent variable and independent variable. Okay, see, if the relationship between the variable exists, then points in the scatter diagram will show a tendency to cluster around a straight line or some curve. Such a line or curve around which the point cluster is called the regression line or regression curve, which can be used to estimate expected value of the random variable y from the value of non-random variable x. Let's start the discussion, a practical discussion of the scatter diagram, and how can we draw a straight line from the help of scatter diagram. Okay, we have a x-axis, y-axis. Okay, the same practice which we have. Okay, see, here we have like these are the outcomes of the x-axis and y-axis, you can see. And if a line can be drawn between these points, then we can say a relationship is existed between the variables. Like if one point is here and one point is here and one point is here, when one point is here, then we cannot draw a line among the or the center of these points. If the line this straight line can cover more of the point, like you can see 1 2 3 4 5 6 7 points are very close to the straight line. So this line, so this line is called the straight line, and this shows that there is relationship existed between the dependent and independent variable. Okay, while with the help of scatter diagram, there are different types of relationship existed. Like the first one, you can say that there is a positive relationship between the x and y. See here, the most of the points are dotted point very close to this line, so we can say there is a positive relationship between the x and y. You can say that independent and dependent variable. Okay, here you see that there is negative relationship between independent x and dependent y. So see, the most of the points are very near to the line which we have drawn, which we technically call the straight line. Okay, here you can see that there is a decreasing relationship, and then maybe in coming session it will become a increasing. So technically this is known as curvilinear or non-linear relationship between the independent and dependent variables. So see, this is positive relationship, this is negative relationship, this is a non-linear relationship, and see here we are unable to draw any type of straight line. You cannot draw a line like that. If you can draw a line like that, so this will not present any type of change in the dependent variable. So see, if you draw a line here, then y will not change and x is changing. So this type of things we can interpret it. There is a known relationship between the independent and dependent variables. So 4 types of relationship existed between the variables with the help of scatter diagram: positive relation, negative relation, curvilinear or non-linear relationship, and here we can say that this is a no relationship between the independent and dependent variable. Okay, simple linear regression model. What do you mean by simple linear regression? We assume that the linear relationship between the dependent variable yi and value of xi of the explanatory variable, this can be written in the form of equations. So here see that we have a dependent variable yi and independent variable xi, and alpha and beta. Alpha is the intercept, you can say it a constant, and beta is the slope, and you are very well aware about the ui. This is a random error which variation which is not explained by the xi. So while talking about the linear relationship, you can see that if a 1 unit increase in x brings that much change, 1 unit increase or decrease in the dependent variable, we can pronounce it a linear relationship. Like in the previous session, you see that here 1 unit change in x brings that change, but in this case x is increasing but y is decreasing. So, and maybe the rate varies. So this type of relation is called the non-linear relationship. Okay, let's see the interpretation of this, that x independent variable are fixed or predetermined values, because x is not controlled by any researcher. So x is an independent variable, you can say it a fixed or predetermined values. And y are the observation randomly drawn from a population. So x is a independent variable and y is a random variable drawn from the population. Okay, ui are the error components. You can say a sorry, you can say a random deviation. Alpha is the intercept coefficient or constant. We can give the interpretation of constant and alpha. You can pronounce it intercept coefficient or constant coefficient at the same time. So beta is the slope coefficient. It may be positive, it may be negative, and sometimes may be zero relationship among a particular type of variables. So these are so technically the value of x decide the value of y, and as much change in y brings as much change in y, as much change in x brings as much change in y is called the linear relationship. Okay, there are some assumptions of error, which error we have discussed in the previous slide, in this slide, that ui. Okay, there are some assumptions for the error. Okay, expected value of error. The expected value of error term should be 0. This implies that the expected value of y is related to x in the population by a straight line. If error is not expected value, mean of error is not, sum of value of error is not is equal to 0, then there may be a chance that no straight line can be drawn. When no straight line can be drawn, then there is non-linear relationship between x and y. So expected value of error must be or should be equal to 0. Okay, variance, you are very well aware about the definitional process as well as formulation of the variance. So variance of error is constant for all variance. So if you have a series of observation and you can find its variance, and if you find the variance of 2 or 3 observation from this series, the variance will be same for the whole series or for 2 or 3 series. So technically this is called the variance of error term is constant. It means that the distribution of error has the same variance for all values of x. So technically in a econometric point of view, we can use it as a homoscedasticity. This means the variance of error should be constant. So see, the expected value of error is equal to 0, must be 0. The variance of error must be same, technically called the constant. Okay, if you have a series of error, we will practically find in coming session that the series of error and 2 errors must be equal to 0. This means the error of one observation is not equal to the error of other observation. If error of one observation is equal to the error of other observation, so technically this is called the serial correlation or autocorrelation. So we can say that the error of 2 observation must be is equal to 0, or we can say must be different from each other. Okay, there is the fourth assumption of the regression. There is no relationship between the independent variable and the error term. You can see it, x is independent variable and error. So sum of the error and the independent variable is equal to 0. So technically we can say that the explanatory variable or variables and the error terms are independent of each other. If they correlate, or if they are increasing or decreasing trend, then our error is not correct. So error and independent variable must be different from each other. Okay, the last one, the last property of the error term, error are normally distributed with a mean 0 and a constant variance. This implies that y are also normally distributed, and you are very well aware about the shape of the error if you have with the shape of the normally distributed curve. So see, if you have a series of error term, and if this series generate this type of graph, we can say that our error term is normally distributed. So error term, so when you draw the error term in the graph, then the graph form in a bell shape form. So this is known a normally distributed curve. Okay, population versus sample regression. This is the main point which your statistics class discuss by the time, and when you reach or when you are studying about the econometrics, so this difference can be more clear to you, that the population versus sample regression. So according to the population regression model, each yi is an observation from a normal distribution with mean is equal to alpha plus beta xi. You are very well aware about y is dependent variable. Here we are using a mean value of y is dependent upon alpha plus beta xi, and the variance sigma square. This relationship can be expressed in as like expected value of y depend on alpha plus beta xi. Okay, we can read it as the expected value of y is linearly related to x, and the observed value of y deviates from line expected value of y is equal to alpha plus beta x. So this shows that if you are deriving error term from this equation, so previously you see that alpha plus beta x plus error term. So if you are going to find the error term from this model, so then you can write it ui is equal to yi minus, so all this part, because error term is situated here, so all this part will go on the other side, become negative. So this can be expressed as, so you can understand that error term is equal to yi minus alpha plus beta xi. But in real world of whole population, but in our case, especially in our case, in behavioral sciences, whole population is not available sometime, then decision is made on sample. The sample equation become as, okay, you can see that yi is equal to, we are writing a only difference is given here, for example, that alpha in place of alpha we are writing a plus beta in place of we are writing b xi plus ei. So while estimating, if you are estimating the population regression, you can write it expected value of y is equal to alpha plus beta xi. But if you are estimating the population sample regression line, then you can write it y hat is equal to a plus b xi. Okay, we can prove it up in a graphically here. Okay, we have a dependent variable, independent variable, and we can draw it a y-axis and x-axis. So we say that here is the x1, x2, x3 and x4. Okay, we are intersecting the points that x1 is cutting the y here and x2 is, see, so this line can be generated. But here you can see that this line is technically called the expected, because we are using a population regression line. So expected value of y is equal to alpha plus beta x. Okay, this is our estimated regression line for the case of population. But when you are are using a sample regression line, you have to write estimated. Here we have a y I hat is equal to a plus b xi, but in case of population you have to write this notation. So this is the notational difference between the sample regression and between the population regression. Okay, see you with an other video with the formulation of regression line.